We're talking about inhibitory neurotransmitters. Inhibitory neurotransmitters. So students in an exam were asked to list three inhibitory neurotransmitters, right? So if you are here to just know about the list of inhibitory neurotransmitters, let's go straight up. Examples include the GABA, that's the what? Gamma-Aminobutyric acid. The other one is glycine, all right? Other examples include like serotonin. Then other examples include things like what? Adenosine, dopamine, and the endocannabinoids. All right. So that's just a list, right? But here now, I just spent time talking about inhibitory neurotransmitters, talking in depth on it because in some exams, this question might be rephrased and they say that write briefly on inhibitory neurotransmitters. You understand? So it's good for you to now just have some one or two knowledge on it. So let's start from the definition. We said that inhibitory neurotransmitters they block or they prevent chemical message from being passed from one neuron to another. Okay, so if this is the presynaptic neuron, this is a synaptic cleft, this is the what postsynaptic neuron. Information is supposed to pass from this neuron and get to this neuron. All right, so inhibitory neurotransmitters will block this information from passing. All right, unlike the excitatory neurons and neurotransmitters are basically what they encourage the passage of this information and they excite the neuron. All right, so the most popular inhibitory neurotransmitter that we have is the GABA, that's gamma aminobutyric acid, the glycine and the serotonin. Okay, the other examples I listed them at the back. So now I'm just trying to talk like GABA now, talk little on GABA, glycine, talk little on glycine. All right, serotonin, talk little on serotonin, you get. So that in an exam situation where they are saying you should write briefly on these things, it's still not a problem to you, right? So for gamma aminobutyric acid, what is the function? They are a primary like inhibitory neurotransmitters in the brain. Primary inhibitory neurotransmitters in the brain. They regulate neuronal excitability and muscle tone, all right? Like they regulate how far the neuron will be what excited. So if the excitation is getting too much, the inhibition sets in. You get. They are involved in sleep because when you want to sleep, you want to relax. You want things inhibited. You don't want to think too much. All right. Then they also what modulate anxiety. How excited you be at a situation. Like let me say for example now, for some of you, if somebody gives you like 500,000, it will excite you. You are crazy and all that, right? But as you have been making money, if somebody gives you like me now, if somebody gives me 5 million naira, I will just collect the money. Probably I will not even tell the person thank you. This is because probably my gamma aminobutyric acid has gotten used to money, so 5 million naira will not excite me. Do you understand? So that's just the function of this gamma aminobutyric. Then what is the mechanism? They actually bind to GABA receptors, they open chloride channels, okay, then they hyperpolarize neurons. This image actually explains it better. This is an inhibitory what? Synapse, all right? So they actually open chloride channels. For excitation, is the sodium channels that are opened. There will be depolarization. So for this inhibition now, chloride channels will be open, there will be hyperpolarization. You get the difference. What are the disorders related to this gamma aminobutyric? Okay, that's if inhibition is not there. So that means there will be steady excitation. Oh, there's nothing to inhibit it, right? So you'll be having anxiety disorders, all right? Like you see some people, they are always happy, they are always making noise in class. I don't like such people. I don't talk much, all right? The epilepsy, insomnia can also set in. Insomnia is when you're having difficulties in sleeping. So that means what? Inhibition is not able to set in to make you sleep, right? And you could see insomnia in wicked people, right? They have problems sleeping because they always think of bad things to do. All right, then moving to the next one, which is what? Glycine. What is the function of glycine? It's an inhibitory neurotransmitter in the spinal cord and the brainstem. All right, it regulates motor neuron activities and reflexes. It is involved in pain modulation. All right, so back then in secondary school, where they are beating us will be resisting cane, will be chesting cane, all right? Why some people where you just touch them with cane, they will start screaming anyhow, right? So glycine is involved in what? You being able to resist the cane, all right? So in secondary school, you're doing it without knowing what was making you resist the cane, but right now you know, right? So what is the mechanism? Binds to glycine receptors, they open chloride channels, then hyperpolarize neurons. Okay, just the difference is what the type of receptors they bind to. Okay, but their action is just same. All right. So what are the disorders involved when glycine is not there to inhibit some processes? Right. So hyper what? Eclepsia. That's a startle disorder. Right. Any small thing you be frightened. Do you understand? The spinal cord injuries, neuropathic pain, right? All of that can be disorders, right? And the third one is what? Serotonin. Serotonin, you could see here, this is an essay on serotonin. You can actually just pause the video to look at it in depth, right? Serotonin is an inhibitory neurotransmitter in various brain regions, all right? Unlike the GABA, which is found widely spread through the brain, serotonin is on specific regions, right? It regulates mood, appetite, and sleep. It is involved in pain modulation and inflammation, right? So it binds to the what? 5-HT receptors, that's the 5-hydroxytryptamine. Anytime you hear 5-HT, that's going to be about the 5-hydroxytryptamine, right? So when it binds to that, it will now activate some proteins and it will now reduce the way the neurons are excited, right? Make the neurons chin up and all that, right? Then what are the disorders? If it is not there, depression can set in, anxiety disorders, migraines like headache. That means your neurons are just tap, 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 tap without anything to slow them down, right? So that's it for what? Inhibitory neurotransmitters and short essays on 3 examples.